So let's continue discussing solving quadratic equations. So we've learned two methods so far to solve quadratic equations. If we can factor, that's the easiest. And then we know that if we have a product that equals 0, one or both of the factors must be 0, right? Then I also showed you completing the square, and that was sort of a way that if you can't factor, you can kind of sort of force a situation where you could factor something, right? And then we were happy about that. Well, guess what? It turns out that we don't actually do completing the square as often as you might think. Okay? Now, the reason we don't is because there's a certain pattern that always shows up. And if you memorize that pattern, then you can just say, oh, okay, I don't have to complete the square because I already know what that's going to end up with. Okay? What I'm going to show you, this pattern, is called the quadratic formula. And I personally think this is kind of cool. So let me work it out. I'm going to work it out by completing the square. All right? And so you can look back on this video later again or pause, but I'm going to work it out. You might not get it the first time. But what I want to do is I want to first of all write the most general quadratic equation. Okay? I want to write one that no matter what quadratic equation you have, it'll fit this pattern. So clearly we have three coefficients. We have three numbers. We have a coefficient in front of the x squared, a coefficient in front of the x, and then we have another number added to those two terms. And you can always rewrite it so that you have something equal to 0. Okay? Now, if we were completing the square, let's say that a does not equal 0, we would get, first of all, we don't like to have a number in front of the x squared, so we would divide by a. Okay, so right now I'm not doing anything different than completing the square. Okay, and now, if we were completing the square, we know that we wish that the c over a was actually the square of half of the second coefficient, to b over a. So I really want it to be b squared over 4a squared. So let me go ahead and do the following. I'm going to add b squared over 4a squared to both sides. Okay, now let me keep going with completing the square, and I know that this is going to give x plus b over 2a squared, and let me now set that equal to b squared over 4a squared, and let me move the c over a finally to the other side. Okay, so now, every time you complete the square with the quadratic, you're going to end up with the blue case. All right, now we already know how to solve situations where we complete the square. We take the square to both sides. So x plus b over 2a is going to be plus or minus the square root of b squared over 4a squared minus c over a. Now, I've got two fractions underneath the square root that I'm subtracting. I have a subtraction, so let me put those under the same fraction. Let me combine those fractions, in other words. So the c over a, I could multiply the top and bottom by 4a. That's allowed. So now I have a common denominator, so I've got b squared minus 4ac all over 4a squared. Okay? Let's keep going. Now, I hope you can see that the bottom is something that it's a perfect square. I can take the square root of 4a squared, and I don't need to have the bottom in a fraction. So let me shrink this, and we'll keep going. So, all right, let's see, let's switch colors. So, let me fix it up just a little bit more. Okay, so let's do this. Let's say x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac, and the square root of 4a squared is 2a. Okay, and that's nice because the two fractions have the same denominator. So let me subtract b over 2a from both sides. So I'm going to get x is negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And I can combine those, make them a single fraction. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you have it. That's the famous quadratic formula. Okay? Let's be clear what we just did. What we just did was we did completing the square. We did that procedure once in a very general way for all time so that we can always capture this pattern and use it over and over again. Okay? Every time you complete the square, you'll get something that corresponds to the box the boxed formula, the boxed expression at the bottom. Okay? Now, let's use our new formula. Let's see if it actually works. Okay? Let's take a really easy quadratic that we already know the answer to. Okay? So, x minus 1 times x plus 2. That's equal to x squared plus x minus 2. Let's say that that was also equal to 0. All right? Now, bear with me now. Pretend that you didn't know that the solution to that quadratic was x equals 1 or x equals minus 2. Okay? So, we first write it out, the problem. Let me do it in blue. Something quadratic equals 0. Okay? Now, let's go back to the general pattern where you have the a, b, and c and compare it to the what I just wrote down. So clearly in this case a is equal to 1, b is equal to 1, and c is equal to minus 2, right? Okay? Because why? Because you can always write, subtracting 2 is the same thing as adding minus 2. So that's why you can think of the minus 2 as plus minus 2, so c is minus 2. All right, so now let's plug it into the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times ac all over 2 times a. And let's simplify that freak show. Minus 1 plus or minus the square root. Let's see, 1 plus 8 square root of 9 divided by 2. That's minus 1 plus or minus 3 over 2. So that's minus 4 over 2 or 2 over 2. So that's minus 2 or 1 that x is equal to. Now, notice that you got the same answer whether you used it, whether you factored or whether you used the quadratic formula. Okay? This was just to increase your confidence in the quadratic formula. But you take any quadratic problem you've done in the past, use the quadratic formula, you'll see that you'll always get the same answers however you did it before. Okay? So that's a very nice, famous formula to use. Now, a few comments before I close. Remember how quadratic equations can have 0 solutions, 1 solution, or 2 solutions? You can tell by the square root part of the quadratic formula. Okay? In this problem that I just did, I had a square root of a positive number. I had a square root of 9 actually, and so I did plus or minus 3 at some point to get my two answers. Okay? Suppose that the square root was 0. Suppose that the b squared minus 4ac, suppose that that whole blob ended up being 0. So then you would have plus or minus the square root of 0. So in that case, you wouldn't have 2 solutions. You would only have 1 solution. Okay? What about if you took the square root of a negative number? Well, that's garbage. You can't take the square root of a negative number. So in that case, you would have no solutions. Do you see what I'm getting at? So the square root tells you how many solutions you have. Square root of a negative number, garbage. That means no solutions. Square root of 0, that means you're going to have one solution. Square root of a positive number, that means you're going to have two solutions.